This is section 4.5. Today we're going to be looking at proving triangles congruent using angle side angle, ASA, or angle angle side, AAS. The first bit of terminology we need to talk about is included side. Now this is the side located between two consecutive angles. So if we have consecutive angles A and B, the included side is segment AB. And we're going to use that in this first postulate, postulate 4.3, which is angle side angle congruence, ASA. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, the triangles are congruent. So if we have triangle B, or angle B is congruent to angle E, and let's say angle A is congruent to angle D, and we have our segments AB and DE congruent, that proves that our triangles ABC and triangle DEF are congruent. Next in the section is a construction. We'll do that together, and there's a proof. We're going to skip that, but let's move on down to theorem 4.1. Here we have angle angle side congruence, so also referred to as AAS. And in this, if two angles and the non-included side of one triangle are congruent to the corresponding two angles inside of a second triangle, then the two triangles are congruent. So in this case, we have angles A and D congruent, and angles B and F congruent, and sides BC and EF congruent, and in that case then triangle ABC and triangle DEF are congruent. We're going to skip the proof of that theorem, and now we're going to look at this example. So the first figure here, we have two triangles. DE is 15 feet in this triangle, and DE and BC have this perpendicular line connecting them. So we have right angles of C and D. We also know that A is the midpoint here, so we have DA and CA, which are congruent. We also have vertical angles here, so these two vertical angles are congruent. And we're asked to find what is the length of BC. So think about this for a little bit. We have a side here that's given, but we have an angle and a side and an angle. And I guess I should point it maybe this way. We have angles that are congruent, an included side that's congruent, and then angles that are congruent again. So if we want to know what segment BC's length is, since we just shown by ASA, or angle side angle, that these two triangles are congruent, we know that BC is equal to 15 feet. Next, I have a problem for you to do on your paper to be collected here. This diagram right here is a template for an envelope. Okay, someone has designed this template. We have the main section of the envelope, and then we have all of these flaps. Okay, this top and bottom flap are isosceles triangles, so that means this side and this side are congruent. It also gives us that this height of our isosceles triangle is 3 centimeters. It gives us that angle NEV is congruent to NVE. And we have these triangles as being congruent triangles. But my question for you is, what is the length of segment PO? PO. I want to know its length. And I'm going to give you a hint. Use the Pythagorean theorem. Now, the Pythagorean theorem is a theorem for right triangles. It's probably been a while since we looked at it, but this theorem is a squared plus b squared equals c squared, where a and b are the sides that are adjacent to the right angle, and c is our hypotenuse, the side opposite of the right angle. So pause your video and work on calculating the length of BPO. Okay, last for this section, we're just going to look at a concept summary here. The 4 different ways of proving triangles congruent. We had side, 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 SSS from last section, and in that, all 3 sides, not my pen, all 3 sides of the triangles are congruent. There we go. With side angle side, we have our sides that are congruent, our included angles that are congruent. With angle side angle, we have angles that are congruent and the included side. Once we have these things proved, then we know our triangles are congruent. And lastly, 2 angles that are congruent and then a side. So those are the 4 different ways we can prove triangles congruent.